GenAI projects in XM, and today I'm excited to dive into the magic behind our latest creation, an engaging AI chatbot for our traders. I believe that most of you have already heard of the term GenAI, which is short for Generative AI. Generative AI is a type of artificial intelligence that is able to produce new, original, human-like content. Compared to traditional AI, which mostly performs data analysis and does classifications and predictions, GenAI is able to produce new content and ideas. GenAI brought a revolution even among non-experts, with millions of people using it daily to produce images, text, audio, and even video. XM is a fintech company that has been using traditional AI and machine learning for many cases like fraud detection and client segmentation. However, we wanted to expand beyond the traditional AI and machine learning and experiment with this new and shiny technology that's called GenAI. Our journey began on August, where the GenAI initiative started, and we formed a team to get familiar with it and explore potential use cases for our company. After some investigation, we decided to build a POC with our research portal content. Research portal is a crucial tool for our traders, since this is a place where they can find important information that will help them take their next trading decisions. Traders can read the latest news, XM research written by our financial team. They can also view the latest trading signals that are produced after analysis from our experts. They can read the next economic events and their impact. And also, they can select a specific instrument. An instrument is a tradable asset like Euro vs Pound, and they can view more information about it with more details like its prices, investor sentiment, user analysis, and much more. The reason why we picked research portal content for our POC was that firstly, it contained a lot of useful information in the form of text, which makes it ideal for GenAI. It does not contain any sensitive data like client data, which is a safe option when you want to experiment with new technologies. And we wanted to increase the user engagement because until now the interaction was static. The traders had to navigate through all this content by clicking many times, and sometimes this useful information would not get the visibility it deserved. By mid-October, our POC was ready. It was very successful, and we decided to build a product out of it and release it to our clients. Right now, the beta version of our application is finished. We are currently passing UAT, and we expect gradual release to our clients in the next weeks. But let me give you a small glimpse of our application. The UI might look familiar to you. We try to keep the same look and feel as ChatGPT because our clients would be already familiar with it. On the left of the application, the traders can view the instruments that are tradable through XM based on their category. They can pick one of the suggested questions about an instrument, or they can choose to type a question on their own. The system will answer the user question using XM Research Portal content like news and analysis in an engaging way. They also have the option to pick one of the related questions to follow their conversation, or even choose to view more insights about the instruments related to their questions, like the prices, signals, economic events, and more detailed information. The application also offers some more possibilities, like bookmarking a chat or regenerating a chat. The front end is built on Angular, it's fully reactive and integrated with mobile, and we also offer a dark mode. The whole idea of the application is that it utilizes all the valuable information from our research portal and creates engaging answers to user questions. So now, a trader, instead of going into our site, clicking many times to find the content they want to read many user analysis, and then take their next trading actions, they can simply ask targeted questions to the chatbot, and the system will do all the work for them. So now you have an idea of what we did for our clients, but aren't you a little bit curious of knowing how we did it? That's why I will deep dive into the technical stuff, like the GenAI technologies, how we use them, the challenges we faced, the architectural decisions we took, and all the geeky stuff. We applied GenAI on text, that's why I will focus on this area. GenAI is powered by large language models. A large language model is actually self-descriptive. It is a large specialized AI model. We're talking about billions or trillions of parameters that's able to understand and produce human language. Some tasks that an LLM can perform is summarization of content, code generation. I believe that most of you have experimented with Copilot, answering FAQs, or performing sentiment analysis, and much more. The most popular type of LLM is, of course, the GPT, Generative Pre-trained Transformer. It's a specialized kind of LLM that follows the transformer architecture introduced by Google. It became very popular by OpenAI, especially since the release of ChatGPT on November 2022. But OpenAI is not the only LLM provider out there. We can find a lot of vendors with a lot of foundation models like Meta, Anthropic, Amazon, Google, and the list goes on and grows every day. But what does an LLM do other than code? LLMs work with prompts. Prompts are broken down into tokens. You can think of a token like a word, but in practice it might be parts of a word with some punctuation. Tokens are internally represented as contextual vectors known as embeddings. If you place the embeddings into the multidimensional space, you will see that the ones that are semantically close are also grouped in the space as well. For example, cat is near the dog, and skateboard is far away. Of course, in practice, we're talking about thousands of dimensions. An LLM takes the sequence of tokens and tries to predict the next token based on the previous ones. The predicted token is appended to the sequence and becomes the input of the next iteration. And the process goes on. LLMs are very powerful, but what can we do with them except for interacting with ChatGPT as single users or using Copilot? How can we leverage their capabilities to build applications on our own? Well, we could train them from scratch. We need a vast amount of data and effort for that, and only a few companies in the world do it. We can fine-tune it, which is the process of retraining an existing model on top of its existing data with smaller domain-specific datasets. Or we can use some advanced techniques like prompt engineering without changing the foundation model. Prompt engineering seems promising. Let's find more about it. Prompt engineering is the process of designing inputs for GenAI models in order to produce the optimal outputs for our case. There are many ways to ask an LLM to do the same thing. For example, you can ask it to create an invitation to a company's summer party in a simple way with simple instructions, but the answer will be generic. If you add more context to the invitation, to the input, like the company name or the party location, you will see that the output will be more specific and it will improve. We can see that adding context to the input helps with the quality of output. There is another popular prompt engineering technique called fusion learning, during which we provide examples in the prompt to drive the model's behavior. In this case, we have provided two examples of headlines and their identified topics, and the model is able to predict the topic of the latest headline without even having it heard. We didn't mention cryptocurrency in our examples. This is done without retraining or training the model, in the sense that we don't change it permanently. We just leverage its existing knowledge with some good prompt engineering. But except for the user message, there is another message that we can define, which is the system message. The system message are the hidden instructions and persona of the chatbot that the developer has defined. In this example, we ask the chatbot to speak like Gordon Ramsay, and the invitation to the company summer party will be adjusted. And that for sure was a party I would like to go. System message can become very complicated, and in practice they contain a lot of detailed instructions. For example, in our case, since we are in fintech industry, which is highly regulated, we need to make sure that the chatbot will not provide financial advice like go buy Bitcoin, so we need to include this instruction in our system message. You can also define some model parameters. I won't go into much details, but I will only cover an important one, which is the temperature. The bigger the temperature is, the more creative and random the model responses will be. A temperature of 0 means that the model will always pick as a next token the most probable one, creating more deterministic and straightforward replies. Most of the times it will imply the same thing. A temperature of 1 means that the model will be more risky and will pick one of the less probable tokens as the next one, creating more
random outputs, which, for example, would be ideal for fantasy story writing. Again, in our case, since we wanted to create a factual financial chatbot, we picked a temperature near 0.1 because we wanted deterministic replies. All of the above, the system message, the user message, the temperature, and much more, can be easily defined inside an HTTP request body, since the interaction with LLMs can be done through REST API, making it easier than ever for developers to interact with them. Let's try to apply the above in our case. This is an example from Azure OpenAI Studio. In our case, we will have financial questions like what are the latest updates on EURUSD? If a user asks that directly to a model, to an LLM, for example, to a GPT, to ChatGPT, it will not be able to answer due to lack of real-time data. We want to answer this question in a specific way using only XM data. For this, we need to define the system message, as I mentioned before, and we also need to augment the user prompt with content that will be used for the answer. The GPT can now answer. It would be nice if we could add here all the XM content we have for all the instruments, but of course, we have token limitations for the input, but even if we didn't have, the input would become huge, the cost would skyrocket, the LLM would get confused. That's why each time we need to retrieve the most relevant content. This is called the Retrieval Augmented Generation process, or else RAG, and it's the most popular way to leverage LLMs with your domain data. RAG consists of 3 steps. The retrieval one, during which we retrieve the relevant content from our knowledge base according to the user question. The augmentation, during which we augment the prompt with the content we have retrieved. And the generation, during which the LLM generates the answer to the user question based on the provided context. So as you can see, there are a lot of technologies, options when you want to design a GenAI system, and inevitably you have to take some decisions. For us, some decisions we had to take was to choose between fine-tuning and RAG, select the model, and of course, pick a programming language for our application. Firstly, we had to choose between fine-tuning and RAG. We covered RAG, but we also saw that fine-tuning is a process of taking a pre-trained model and further training it on smaller domain-specific datasets. So that makes fine-tuning also a popular option when it comes to domain-specific chatbots. Fine-tuning is known for its consistency. It can also cover edge cases, since you can provide many examples of the case that it underperformed, and it will finally learn to handle it. It minimizes prompts, because you don't have to provide as much context and examples in the prompt, which has an impact to the cost, of course, and enables low latency requests. However, there is additional cost for training the model and hosting your own model, and it requires a lot of effort and technical expertise to train a model. Training can be tedious, especially due to the lack of transparency. You cannot easily tell why a model responded the way it did. You see it as a black box. This is a common issue with traditional AI and machine learning. It is ideal if you have large amounts of highly curated data, and if you want to customize the tone and format of a conversation. RAG, on the other hand, is more adaptable with smaller feedback loops. It's less prone to hallucination because you ground it to a specific context. You tell it, answer from this context. It's more scalable because you can grow your knowledge base without having to retrain the model. But it lacks on speed, it's slower due to the retrieval step, and the prompts can become very complex and hard to debug. It's ideal for an evolving knowledge base and for real-time data. What we also see in the industry is a hybrid approach where you can use both fine-tuning and RAG. For example, if you design a client support chatbot, you can use fine-tuning with many examples from your current client support for the model to learn the brand, the tone, and the format of the answers based on your brand. And you can feed the model with client data to answer their questions through RAG. Let's see our content that will help us decide which one to choose. We have prices, events, news, trade ideas. All of those are real-time. They're changing every second, if not millisecond. So our only option is to use RAG. But even if we didn't have such dynamic data, again, we would not go with fine-tuning because according to OpenAI guidelines, fine-tuning should be your last resort if you are unable to achieve results with other methods, because it requires a lot of effort, of course. The next step is to pick a model. As we saw before, there are a lot of foundation models out there. And when picking a model, you have to consider those 3 factors: speed, precision, and cost. As much as we desire, we cannot have it all. For example, a smaller model like Amazon Titan Lite, it can be very quick and cheap, but lacks precision. And on the other hand, GPT-4 can be impressively precise, but it's slower and costs a lot. After many experimentation with models from AWS and OpenAI, we decided to go on with Azure GPT 3.5 because it was a good compromise between those three factors. However, application is fully integrated with many models, and it's easy to change the model by changing the configuration. We also chose to go on with Azure OpenAI and not directly OpenAI because Microsoft offers GPTs as managed services in Azure Cloud. You can deploy the models you want in the regions you want, only your organization has control over them, and they're only accessible by you. And it was time to write some code. We are developers after all. We like to write some code. We had to choose the programming language of our application. Of course, Python seems like the default choice because it's known for its big and evolving ecosystem around AI services. A lot of LLM frameworks like LangChain or Llama Index are developed in Python. However, we did a plot twist, and we didn't pick Python. We chose Golang instead for the following reasons. We already have a lot of experience in developing and productionizing in Go compared to Python. XM has a really large Go community with more than 60 Go developers, and we're still growing. Go is known for its performance, scalability, and low resource consumption. We have seen it in practice, and we really like it. And we plan to do a lot of concurrent calls, like parallel API calls. So we liked the simplicity and the flexibility and performance of Go concurrency. We had to implement some logic on our own because there are not a lot of already made tools. However, we deeply understood how stuff works, and now we have full control of our flow. I was at a Go conference recently, and the product manager of Google mentioned that they're working on making Go the ideal language for productionizing GenAI-powered applications. And to be honest, I'm looking forward to it. And now that we took some decisions, we have to implement the retrieval part. We are designing a RAG after all, so retrieval is very important. Let's deep dive into our knowledge base to help us take some decisions about the retrieval. We have news and analysis, which contain a lot of rich data with some metadata. We have trade ideas and economic events, which are more structured data with not a lot of text. And candles, actually prices in the form of candles, which consist of mainly numerical data. The challenge here is to find how and when you will retrieve all this data so that they are useful to feed them to the LLM and produce responses to the user. For example, if the user asks, how will elections affect Euro-USD, we will need data from this article. European markets favor Biden over Trump. The LLM will understand how to use the article to answer the user question and will answer that according to the latest news. If Biden gets elected, Euro-USD is expected to go up for the following reasons. I will try to remember that. We need somehow to associate the user question to the article. To achieve this, we need to perform semantic search using embeddings. If the two embeddings are close, this means that the question with the article are semantically related, and we can use the article to answer the user question. So we create embeddings, numerical vectors, from our news and analysis, and we store them in a vector DB. For vector DB, we have chosen Elasticsearch because we already have production experience with it, and we like the flexibility and control we had with the Elastic queries. It was easy for us to ask for the semantically similar news, but also boost the ones with the latest update date or the latest published date, since we wanted fresh news. To populate our vector DB, we created a cron job that runs every 10 minutes, uses an OpenAI embeddings model, gets the news and analysis from the APIs, converts the text using the embeddings model into numerical vectors, embeddings, and stores them in Elastic. This is how our Elasticsearch index looks like. We do the semantic search using vectors field and using some other fields like date. Okay, we want to be able to also answer those questions as well, like what is the current price of Euro USD? Is Tesla stock expected to go up? For some of them, we don't necessarily need semantic search. For example, the question, what are the latest prices of Euro USD, can be answered by simply fetching the latest Euro USD prices from our API using the instrument parameter. To be able to perform these queries, we need to infer the API parameters, and that's why, again, we need the help of an LLM for that. We have included a pre-analysis step during which we ask the LLM to infer those parameters for us, to infer the API parameters. The response comes in JSON if we instruct it to do so. This is called the JSON mode, and it's very useful when you want structured information from an LLM. In this case, we will be able to extract the instruments related to the user question from the instrument's JSON field. The extracted instruments are also used in the UI so that the user has the option to view more insights to the instruments related to their question. Okay, so now we have retrieved all the content, we have the user question. Can we augment the prompt and generate the answer? Is this enough? What if the user asks, what are the latest news on Euro USD? The bot answers and then follows up with, what is the current price? If we only provide the above content to the LLM, it will get confused. What is the current price? What does that mean? The interaction with LLMs is stateless, meaning that it does not keep any state or history of your previous interactions. Each time, you have to provide in the input all the information needed for it to produce the answer. That's why we have to implement something similar to what ChatGPT does under the hood, keep the history in a database, and use it in subsequent queries. This was indeed a challenge because we had the retrieval part as well. What we did on the first version, we concatenated the latest 3 user questions, 2 if we only had 2, and during the generation, we were passing to the LLM the latest 3 user questions with the answers. If the history was big, we were summarizing. But this approach came with a drawback. We ended up retrieving also irrelevant content if the user changed the subject. For example, in this case, we will also retrieve content from Amazon, although the user asked only about the current price of Euro USD. The model is clever enough to understand what is the latest user question and answer that using only the relevant content. But why augment the prompt with possibly irrelevant content and history? A risk to confuse the model and also increase the cost of the input. There are a lot of strategies around this, like creating embeddings from user answers and using only the semantically similar in the history, or ask the LLM each time if the user has changed the topic and discard the previous history. But our final approach was to create one and only one user question that would include any additional information from the history if needed. That's why during the pre-analysis step I already showed you, we ask the LLM to create a standalone query from the history. So if the user asks what are the latest news on Euro USD and follows up with what is the current price, the question will be transformed into what is the current price of Euro USD. So now that we managed to retrieve everything and handle the history, it's time to augment the prompt and generate the answer. I will show you some of our prompts. Of course, those are super minimized versions. In practice, our prompts are more complex, but I don't want to reveal all our secrets. This is a system message where we make sure that the chatbot will not provide direct financial advice, as we saw. This is the user prompt, which we augment with the retrieve news, trade ideas, and this is a prompt also used from the LLM to answer the user question. We're passing the user question and the LLM will answer. The answer to the user question is not the only one that we return to the user. As we saw in the demo, we returned some related questions and a title. That's why, again, we ask the LLM to generate them for us with those two prompts. The first one generates follow-up suggestions, and the second one generates the title. And all those requests happen in parallel. We also produce initial suggestions based on this instrument. We want those suggestions to be updated and very fresh. That's why we have created a cron job that runs every 24 hours, retrieves the latest news and analysis from the instruments in XM, uses the LLM, and produce some suggestions based on the fresh news. We then store them in the database. So now let's put everything together and see the final architecture of our system. This is a simplified version, but it captures the main flow. Let's take it step by step. What we do offline is to ingest the data sources that will be used to generate the replies. For news and analysis, as we saw, we use the OpenAI embeddings model and create embeddings from the textual data. Then we store them to Elasticsearch. For candles, events, and ideas, we don't do any specific pre-processing because we can retrieve the content we want. We can retrieve the information we want from the API parameters, the most important of which is the instrument. And when the user question comes, we do the pre-analysis step. We ask the LLM if the question is financial. If it's not, we don't bother retrieving content. We just answer that this is out of our chatbot scope. During this step, the LLM also infers the instruments and some other API parameters, and also transform the user query to one that contains information from the history if needed. Based on the instruments and some other API parameters, we retrieve the relevant prices, events, and trade ideas. And in parallel, we perform semantic search into our vector DB to retrieve the relevant news and analysis. We augment the prompt with all the relevant content, and we ask the LLM to generate a response for the user, follow-up suggestions, and a title. The LLM is clever enough to understand how to use the provided content and produce an optimal response to the user question. Okay, now we developed the application. Let's start thinking about deployment. When you want to deploy such an application or any kind of application, you have to take into consideration the stability, the scalability. Ideally, we want to scale to millions of users, the security, and the cost. Our infrastructure is deployed on AWS EKS, so this is where we also deployed our backend application. For the API with which the user interacts, we have deployed 3 pods, one in each availability zone. And Elasticsearch is also deployed in EKS. We don't use the managed AWS service OpenSearch because we wanted the latest features from Elastic. Our application uses server-send events, SSE. Server-send events is a technology that allows a web server send updates to a client through HTTP, making it ideal for streaming responses. Compared to WebSockets, SSC establishes one-way communication, allowing only the server to send events to the client, whereas WebSockets establish full two-way communication. SSC is considered simpler and safer than WebSocket. It's widely used for AI chatbots. That's why it was our choice as well. However, we faced a challenge. A major challenge we faced is that usually we have an API gateway in front of our backend services that also performs the authentication part. The API gateway, however, was not supporting SSC. It was waiting for the whole response to come back and then returning the response as a whole to the user, ruining the streaming experience. That's why we used an application load balancer instead that can indeed stream the response. And ALB is accessible by Akamai, which is our CDN. Now the authentication is done by Istio. And this is the final infrastructure. You can see that at some point we have achieved scalability and high availability with EKS and security with Akamai, but we have done it for our infrastructure. How can you ensure scalability if you're dependent on external APIs like Azure? Azure enforces some strict rate limits per region. That's why we had to deploy multiple GPTs instances in multiple regions and configure our API client switch region when they hit the rate limit of one region. An optimal solution to that would be to have multiple instances deployed of Azure and AWS deployed in many regions around the world, and navigate the client traffic to them according to the client's location. That, of course, means that our infrastructure needs to be deployed in multiple regions around the world, and this is something we consider for the future. So, as you saw, when designing GenAI systems, there are a lot of challenges and opportunities. One challenge is to always pick the best model for your case. Models are released all the time, so we have to evaluate them and see if they fit our case. The cost is another challenge as it can skyrocket, especially if you want to scale to millions of users and millions of requests. Also, LLMs tend to hallucinate. This is a known issue, and there is no standardized way to evaluate them. And multilinguality can be also tricky, as many models do not perform well in certain languages. But also, there are a lot of opportunities with new technologies emerging each day. We plan to use function to calling, which is a more standardized way of calling external APIs and internal functions. We will use Assistance API, which provides some more features like code interpreter, where the model can actually run code for you. And of course, the possibilities are endless. We can talk about personalized AI trading assistants, client support chatbots, client performance assistants, and many more. And if you want to explore those possibilities with us, you can come work for XM. XM is an award-winning international online trading firm with more than 5 million clients around the world. The headquarters are in Cyprus with offices in Athens, Thessaloniki, UK, Australia, US. XM has more than 1,300 employees globally, half of which are IT, and multiple Great Place to Work awards. Come visit us to our booth. We can have interesting conversations. You can spill the wheel to win presents. And you can also join our lucky draw to win a PS5 until Saturday, 1:30 p.m. The winners will be announced at Saturday, 2 p.m. Thank you very much.
Thank you, Maria.